we are moving on to this part. So I want to ask you some questions, everyone, okay, regarding some basics, which is pretty much required for continuing to the advanced module. Okay, number one question is, what is the difference between TCP and UDP? Number two, what is what are the layers of TCP/IP model? Number two, what is an IP address? What are the ranges of IPv4 addressing? Number four, what is subnet mask? Why it is? Okay, so this four questions, everyone. Okay. Prakash is there. Prakash.
Yes, sir.
Yes, Prakash. You tell me the first question.
Okay. So first question is, what is the difference between TCP and UDP? So TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. Okay. So difference between TCP and UDP are TCP is slower compared to the UDP. UDP is fast in terms of that, and TCP provides guaranteed delivery of data, and UDP does not provide the guarantee of the delivery of the data. TCP provides the ACK, and UDP does not provide the ACK. ACK stands for Acknowledgement Packet. Okay. And TCP is connection oriented protocol, and UDP is connectionless protocol.
Okay.
And port range is TCP UDP port range number 02655535, and 021023 is reserved for protocol or services. 1024249151 is reserved for software apps development by organizations, and then 49152 to 65535 is range for dynamic usage.
Okay, very good. So what exactly is the reason, Akash, for
yes,
TCP is slower and UDP is faster?
I'll tell you, sir.
You told me that TCP is slow and UDP
yes,
is
sir.
fast, right?
Yes,
but
sir.
What exactly is the real reason behind TCP is slow and UDP is fast?
I'll tell you, sir. Wait a second.
Yes, Akash.
Wait a second. I just say it here. Sorry. Sorry, sir. I think because I think TCP have the 4 layers of layers, so it will take more time than the UDP.
No, that is TCP/IP model, no? We're not talking about TCP/IP model. We're talking about transmission control protocol, right? It is your layer 4 protocol. So
sorry, sir.
You have TCP and UDP working at layer 4, right? So why TCP is slow and UDP is fast? This is the question. That is basically a counter question. Okay. Do you know?
Yes.
You have that 3-way handshake process in TCP, right? Akash, can you remember? You are having 3-way handshake process in TCP. First way, second way, and third way. Remember that? In the first way, we send a synchronization packet from sender to receiver. From receiver side, we get a synchronization plus acknowledgement packet. And
Sorry,
in the
sir.
third way,
I
we
don't
send an
know.
acknowledgement packet to the other side, right? That is the TCP three-way handshake
Sir, it
process. Hmm. Okay, anyways, uh, Ankita is there. Ankita?
Yes, sir.
Yes, Ankita. You tell me the second
Uh,
question.
what is the layer of TCP/IP model? It has 4 layers:
Hmm.
network, SS, transport, and application.
Which one is layer 4?
Application layer,
Layer 3,
transport,
layer 2,
internet
layer
access,
1.
and network access.
Okay. Your application layer in TCP IP model is the combination of which layers of OSI model?
Data link layer and
No,
physical.
no. Your application layer in TCP IP model is the combination of which layers of OSI model?
Uh,
This TCP IP model was built,
Application, presentation layer, and session layer.
that is correct. And your network access layer is combination of which layers?
Uh,
Network access layer?
is transport and
No,
network.
no. Your network access layer is a combination of physical and data link layer, na?
Okay, sir.
Physical and data link layer. Okay. Next, uh, any is there? Any?
Yes, sir.
Yes, you tell me this third question.
What is an IP address? What are the ranges of IPv4 addressing? IP address is a logical number that provides an identification to a device host over the network. And there are 4 classes of IPv4 addresses. Sorry, 4 ranges. So class 1 is from
Four ranges.
class
Any?
4. There are 4 classes
No,
of IPv4
no,
ranges.
no. There are not 4 classes.
So class A, class B, class C, and class D.
No, that is not correct. How many ranges you have? How many classes you have in IPv4? Any?
Yes.
How many ranges you are having?
So sorry, sir. That is public and private. I was talking about public and private.
So those are basically types, right? Types
Yes,
of
yes,
IPv4.
yes.
Yes.
It has 2 types, public and private. And that
Yes.
ranges I was talking about was public.
Yes, but in the public range or in the public type, you are having how
Yes,
many classes?
4,
5 classes. And,
5 classes. Yes. Class A, class B, class C, class D, and E.
and in the private,
Private, there are 3 classes.
what are those?
Class A, class B, and class C.
Okay, now tell me the ranges.
Of public or private?
Public and private both.
Public class A is from 1 to 126, and 127 is reserved for loopback. And from class B, 128 to 191. Class C is 192 to 223. Class D is 224 to 239. And class E is 240 to 255.
Okay. Then
And private ranges is for class A, 10.0.0.0 to 10.255.255.255. Class B is 172.16.0.0 to 172.31.255.255. And class C is 192.168.0.0 to 192.168.255.255.
And what is the global broadcast address?
255.255.255.255.
Good. Next, Jabroto. Jabroto.
Yes, sir.
Yes. The fourth question.
What is subject mask? Subnet mask, sorry, sir.
Yes.
Sir,
Subnet mask.
so not remembering right now, sir.
Not remembering right now.
Oh, yes.
What happened? Jabroto.
Yes, sir.
What happened? Not
Uh,
revised.
no, I revised, but what is subnet mask? No, sir, not remembering right now, sir.
Okay.
I forget.
Okay. Just revise all these things. Okay. We require all these things in the advanced.
Obviously, sir. Obviously, sir.
Okay. Let me ask Priyanshu. Priyanshu, come in. Priyanshu is there?
Yes, sir.
Yes, Priyanshu. You go on. Fourth one.
So the subnet mask. So subnet mask is actually a mask provided to the IP address, and it consists of two parts: network part and the host part. It tells us about the network and the host.
What are the subnet masks we are having?
Subnet mask. Subnet mask is
What are the
subnet
subnet
mask.
masks? For class A, B, C, what subnet mask we have?
Yes, a class subnet mask are four types: class A, B, C, and D.
No,
Class A.
class B, you don't have subnet mask.
192, whatever. Class B.
You are having only 3 subnet masks, right? 3 classes. Okay,
Class A.
Vikram. Vikram.
Yes, sir.
Yes, you tell me.
Hello, sir.
Yes, go on.
Subnet mask is a logical subdivision IP network, sir. It contains, sir, network part and host part, sir.
And what are the default subnet masks we have?
Default subnet mask 255.255.00.
For which class it is?
Which it belongs to, sir, class D.
Class A is?
What, sir?
Class A subnet mask is what?
Class A subnet mask, sir. 155.0.
Oh. Okay.
1.
Bhaskar.
Yes, sir.
Tell me.
So basically, our every IP address consists of two parts: network part and the host part. And subnet mask is used to identify those things: network part and the host part. And the ranges of subnet mask is, and in that also the network part will be represented by the bit 1, and the host part will be represented by the bit 0. Like in class A, our subnet mask is 255.0.0.0. It means that our first 8 bits are reserved for the network and remaining 24 is reserved for the host. In class B, it is 255.255.0.0. Means that 16 bits are reserved for the network and the remaining 16 for host. And class C is 255.255.255.0. Means starting 24 is reserved for the network and remaining 8 for the host.
Very good. Okay. Now, tell me one thing. Okay, this is a counter question to you, Bhaskar.
Yes, sir.
You told me that a subnet mask is having 2 parts, right? Network
Yes,
and host part.
sir.
Why
Yes, sir.
exactly a machine requires the subnet mask when it is configured with an IP address, why it is mandatory to give a subnet mask to a machine? Supposing your laptop is connected, okay,
Yes,
in a
sir.
network, then you
Yes,
have
sir.
to give an IP address to your laptop, right?
Yes, sir.
Yes. So to
Actually, sir.
communicate, you need
Yeah,
an IP
sir.
address, and this IP address always takes a subnet mask. Without it, an IP address is not valid. Okay, your IP
Yes,
address
sir.
configuration is not valid. So why exactly machines, okay, they depend on the subnet mask so much? Why it is like that? You
Because, sir.
understood my question,
Yes,
right?
sir. Yes, I got it.
Hmm.
Uh, because, sir, first of all, when we get the actually when we get the internet connection from our service provider, so we will get a particular IP class. Means, address space we will get basically. So basically, subnet is required to divide that address space into the means you can say divide that a larger network into a smaller network.
No, that is subnetting. We're not
Yeah.
talking about subnetting. That is subnetting. That is a different concept. We are going to be discussing the subnetting, okay, in this module as well. But what you are saying, that is, you are dividing one big network, you create small networks, that is subnetting concept. I'm not talking about subnetting, Pascal. I'm asking about your machine, when it is configured with an IP address, why it is mandatory to give a subnet mask with an IP address, without which your machine cannot consider this IP address as a valid IP address. Why it is like that? For example,
Because sir, by that only we will come to know that our machine is part of which network, and that with
yes,
because
we come to know. Do means you are talking about us. We are coming to know that machine which belongs to which network or something else is there.
I think routers.
For example, let's talk about this machine. This
Yes,
is
sir.
your laptop. When you are configuring, let's say you are configuring 192.168.100.1, right? I have not configured the subnet mask, right?
Yes, sir.
Here I have not configured the subnet mask. I just configured the IP address. But if I simply just click on anywhere else over here,
Automatically.
you can see the subnet mask also automatically it is coming.
Yes.
Right?
Yes.
Because machines that are dependent on the subnet mask for some reason, right?
Yes, sir.
What I'm trying to say over here, that why this thing is mandatory, why it is mandatory for a machine to have it when it is configured with an IP address. Why? Are you getting my point?
Yes, sir. I got it, sir. Sorry, sir. That I don't know.
Okay. Okay. Now, who can basically give me the answer for this? Who can give me the answer? All of you have got the point, right? What I'm trying to say, all of you. Yes, Vandana. Vandana, come in.
Yes, sir.
Yes, you tell me.
Sir, in subnet mask, we found out the network part and host part of any IP address. So if we have given IP address like 192.168.0.0, so we can find out that how much host address we have and how much we can give IP address to other devices. Like we have 15 devices and I have given one IP address. So I will find out how much host address it has. And I can provide IP address to those 15 devices.
That is when we talk about the concept called subnet mask, at the time it is coming, right? When you are using subnet mask, at the time you are having all these values are coming, which you are saying, right? The host address, the network address, all these things are coming in the concept of subnet mask itself. I'm not talking about this. I'm talking about this machine why it is required to be configured as subnet mask, what exactly it really mean for this machine, what does subnet mask really mean for this machine. From the machine's perspective, I am asking you. I'm not asking you from the subnet mask perspective. It is your laptop, okay? And this laptop, you have it configured with an IP address and a subnet mask. When you are giving subnet mask, what this machine understands, this is what I am trying to understand.
So the subnet mask is used to determine whether the host is on local subnet or on an remote network. So you can use for that also.
Okay. So by configuring a subnet mask, you were saying that this machine, whether it belongs to the local LAN or to any other LAN.
Yes, sir. So maybe I am wrong, but
how do you say this? When I give this mask over here, how the system understands that this machine, whether it belongs to the local LAN or remote LAN? IP address is
sir, by using host
static
and network. Sir, by using host and networking bits.
Host and network bits. Okay.
So network bit is 111 and host bit are 000. So a machine can identify by using networking and network bits and host bits.
That is coming. See, the concepts what you were referring, right? That is coming in subnetting. Okay. You guys are referring to the concept of subnetting. Means when we are modifying the values of subnet mask, this is when exactly the network host bits are getting different. But right now, if I have another machine over here, okay.
Sir, it is to identify network part
like
and host part.
Yes, that is the definition, right? That is the definition of subnet mask over here. The network and host part identification, we are doing it. But right now you are having two machines, right? This machine is 192.168.100.1 and this machine is 192.168.100.2. So I am asking you from this machine's perspective that what exactly this mask really mean for these machines. When we are doing IP address configuration, what this mask really mean for these machines? What do they understand out of this subnet mask, what we are giving when we are configuring an IP address? From machine's perspective, everyone, not subnet mask's perspective. You guys are getting my question, right?
So for dividing a huge network into smaller networks, sir?
Oh, that is subnetting. This is subnetting.
Sir, got the point, but I don't know the answer. It's like we know now ki, you are asking that why we need a subnet mask for the device.
Yes, sir.
Yes.
But I don't know the
like
answer.
what? These are two perspectives. Okay. It's what you are saying, that is correct only. Okay, but the perspective is different. Okay, subnet mask we are using for network and host part identification purpose only. Okay, but the way I have asked this question, I have asked you from the machine's perspective, from your laptop, from your desktop's perspective, I have asked. So the very simple way to answer this is, since it is your machine, right? It is your machine which is configured with an IP address. Your machine needs to know that in which network it belongs. Your machine needs to know this, that in which network it resides. This is when we are identifying it using the network part. Getting my point? We're identifying this using the network part from the machine's perspective. And similarly, the host part, why we are using the host part? Because when your machine belongs to a certain network, it needs a unique identity. Okay, because we have lots of machines. These two machines belongs to the same network. 192.168.100 is the network part. One is the host. So this one over here, it establishes your machine's identity uniquely on the local LAN. Because over here we are having two, right? Yes or no? This is two.
Yes, sir.
This is one. The same thing, okay, what you said, that is correct, but you said it from the subnet mask perspective. I said it from the machine's perspective. From your machine's perspective, what exactly this host part is used for? It is basically for identification of your machine in the local LAN. We are using it. And this particular part, we are using it in order to identify this machine in the LAN. Okay, means the machine's network. What is this machine's network? This is what exactly this part identifies. Are you guys getting it right now?
Yes, sir.
The same thing, what you said, I'm not telling you anything different. I'm saying from your machine's perspective. Okay, in interviews, okay, be ready to face this type of like what questions, okay. They will ask you the same thing, what you already know. They will ask you the same thing, but their way of asking, it is a little bit different. Okay, they will not ask you like what straightforward questions, like what is subnet mask, what is IP address. They're not asking you like this. They will give you a situation, okay, and they will basically ask you that, okay, tell me what exactly should I do on this machine to communicate to this machine. A situation like this. Always they are giving you certain related environment where you have to explain what you will be doing, okay, regarding technologies to manage their network, because ultimately you'll be managing their networks. Their network is already made up of all these laptop, desktop, server, and all these machines. So they will give you certain like what situation based questions, okay, like always examples, okay, they will be giving you that. Let's say that you have this many number of machines, you have this many number of like what servers are there, what you will be doing to configure this, how you will be making communication to this, okay, like that. Always they will give you certain circumstances, okay, which is real time based. So the same thing, okay, they are asking you from a different perspective. From the machine's perspective, they are asking. They are not asking you what exactly is subnet master. They're asking you that why exactly this machine requires a subnet mask. Why exactly it is mandatory to configure a subnet mask? Because it is this mask only which this machine it uses to identify its existence on a certain network. And similarly, what exactly is the identity of this machine on that network? This is the mask which basically tells this machine that. That's getting my point, all of you.
Yes, sir.
So, from the machine's perspective, I'm asking, okay, nothing else.
Sir,
But
one question, sir.
All of you have got like what you guys have given me the answer, but subnet mask perspective, like straightforward answer you have given on a straightforward question. Okay, first of all, read the question properly. Okay, if you are having some trouble understanding the question, then again, like what, ask. Okay, ask the question. Okay, ask for clarification. What exactly they are uh, trying to ask. Just make the clarification, and after that, provide the answer. Okay, because when you will be going through interview, there is a technical round. You guys know, right? All of you, there is a technical round there. Okay, in the technical round,
Yes,
they will ask you this type of questions. Okay, so make sure that you understand the question what they are asking first, and after that you provide the answer. Okay, always like what use this approach. Anyways, what exactly we are discussing right now, everyone? That is your
So one question.
tell me.
Yeah, you are explaining about the TCP UDP difference.
Difference.
Yeah. So as you said that
Yes, go on. Go on. Who was asking the question? Yes, who was asking the question?
hello.
Yes.
Hello.
Akash,
Yes, sir.
right?
Yes, sir. Yes, sir.
Yes, go on, tell me.
So you are talking. You are telling about the why the TCP is slow. So I did not catch up that time. So can you tell me once more, sir?
TCP, it is slow because of the reason that you are having three-way handshake process.
Okay.
The TCP three-way handshake process is there, right?
Yes, sir.
In the first way, we send a synchronization packet, right? SYN
Yes,
packet.
sir.
From
Yes, sir.
sender to receiver it goes. Then from receiver side, we get a synchronization
Sync
plus
plus
acknowledgement packet,
acknowledgement
right?
packet.
And lastly, we are sending back an acknowledgement packet back to the receiver, correct?
Okay.
This three-way handshake process, whenever it is getting completed, this is when exactly the connection is declared as established, right?
Okay. Yes,
This
sir.
is the connection which is declared as established. And whenever a connection is declared established, it means that whatever information we are exchanging via that connection, it means what? It involves sending data and receiving acknowledgements. Always.
Okay.
You send something, you receive acknowledgements.
Yes,
Okay,
sir.
that is why we are calling it connection oriented. That is why TCP comes in connection oriented type of communication. Reliable, always. Okay. Because
Okay,
whatever data you are sending, you receive an acknowledgement that the receiver has received your data. Okay. For example, if you are sending a mail via Gmail, okay.
Yes, sir.
If the mail is delivered, you get an acknowledgement, right? That the mail
Yes,
has
sir.
been delivered.
Yes,
If
sir.
the mail is not delivered, at the time you also get the message, right? In Gmail,
Yes, sir.
the mail is not delivered. This is the
Yes,
type
sir.
of acknowledgements you are using.
Okay.
When you send mail, at the time you use the layer 7 application layer protocol, SMTP, simple mail transfer protocol. Okay.
Yes, sir.
And SMTP at layer 7, it works with TCP at layer 4. Okay, SMTP uses TCP to build connection. Getting my point?
Yes, sir.
So since it is using TCP and TCP's behavior is what? Sending data, receiving acknowledgements, right? That
Yes,
is the
sir.
reason you are getting like what? Mail sent message. Okay.
Yes, sir.
Then mail not delivered type message. Okay. Always you receive an acknowledgement.
Yes, sir.
And UDP is not basically using any of these mechanisms to establish a connection. This three-way handshake process is not available in UDP. That is why exactly UDP is simply just delivering the information what you were sending and doesn't bother about any information like what any receipts or any acknowledgements. Okay. So
Okay.
your job is to send data only. You are not bothered
UDP.
about whether the data you have sent is received by the receiver or not. Getting my point?
Okay. Yes, sir.
This is the reason we are considering TCP as slow, because TCP performs all the three-way handshake process to build the connection. UDP doesn't consider any of this, like what handshake process over here.
Handshake
That is
process.
why UDP is fast.
UDP is fast. Okay, sir. Thank you, sir.
Understood.
Yes.
Sir,
Okay.
one question, sir.
Tell me.
Sir, in the same example, the Gmail application one. So, what will be the role of session layer, sir? Means, actually, sir, I'm
Session
having
layer,
confusion between the
login.
session and the.
You log into Gmail server, no?
Yes, sir.
Yes. So when you are logging into the Gmail server, after logging in only, you can like
Okay.
what send and receive mail, right?
Yes.
Yes. So means what? During the login time, your session is getting created with the Gmail server. Then the amount of time you spend on your mailbox, okay, whatever you do over there, that is you are maintaining the session with the Gmail server. And when you are done sending mail, you are simply just logging out, right? That is your
Yes.
logout terminated. Session is terminated.
Okay. And sir, one more question, sir, I'm having.
Tell me.
Sir, like you mentioned in the subnet mask one, that that machine, with the help of subnet mask, it's able to identify that which network it is part of. So, sir, means what the machine will be going to achieve, knowing this detail that I want to know.
Again, tell me. Again, tell me the question again.
Sir, like you said that a machine uses subnet mask to identify that which network it is part of, correct? So what that machine actually going to achieve by knowing this detail? That I want to know. Because in real time, our IP address only will be coming into picture, and
our IP address.
I mean, in the real time when the network communication will happen, so at that time only our IP address will be going to come into picture. Correct?
No. Subnet mask always will be there. Basically, you are having this. Okay, when your information will be going right, when your packet is going from one machine to another machine by a network, this is when it will carry the subnet mask as well with it. Without subnet mask, nothing is moving. Okay, IP address and subnet mask, these are basically two things, but they always move in together. Getting my point? When your network layer adds packet, okay, this IP address and IP addressing information, they will include the subnet mask along with it. Okay, and basically, whenever we are communicating in our LAN, then we are not that much bothered about what mask exactly is there, because like what, they are part of the same network. But when it is moving to other LAN, this is when exactly your router needs to know that what exactly is the subnet mask you have on your IP address, because that is the way the router performs routing. If he sees that the mask is different from the mask what you are using in the destination, then it immediately routes the informations to other labs. Getting my point?
Okay, sir.
You will come to know all these things when you will do routing. Okay, all these configurations are coming up from here. Anyway, so
Okay,
we are
sir.
moving
Thank
on
you,
to this particular section, everyone. As all of you have told me that your subnet mask, exactly, it identifies this network and host part in the IP address. Network part, we are using it to identify the device's network itself, means these devices, they belong to which network. This is the identification what is being provided by the network part in the IP address. And similarly, the host part identifies the host's identity itself in the network. Means in this local area network 2, what exactly is the host's identity? This is the part which is identified by the host part. So for that reason, we are having the default subnet masks, class A, class B, and class C, when we are using this simple formula of zeros and ones over here, where 0 means host bit and 1 means network bit. And this is the conversion of the subnet mask of class ABC, which is going on over here. Okay, so if we are converting, because always we are writing these values like IP address, subnet mask, everything in decimal format. So all this decimal, it is easy for us to understand, but the system always uses binaries. So this is when we are doing the binary conversion. So decimal to binary conversion goes like this: 255. We're having 8 bits. All these are octets, and octet is all about 8 bits. We're having 8 ones we have for 255 conversion of binary, and similarly 0. We're having 8 zeros. So these zeros and ones, if we are converting over here from this, then 255.0.0.0, simply it goes like this: 255, which is your 8 ones, then you have 0 in the second octet, so 8 zeros are coming in binary, then again 0, 8 zeros are coming, then again 0, 8 zeros are coming. Similarly, class B, we have 255, 255, we have first 8 bits 1, then second octet 8 bits 1, that is total 16 bits, and over here 8 zeros and 8 zeros, so 0.0. And lastly, we are having 255, 255, 255.0. So we have 3 octets. This is your ones, and 8 bits we have in the last octet. Okay, so clearly you can see how many ones and how many zeros are there. And this is simply just written over here. Okay, 8 bits network, 24 bits host in class A, 16 bits network, 16 bits host in class B, and 24 bits network and 8 bits host in class C. And this is a very, like what, very popular formula what we are using to find out every single IP addresses, network and host point. So example wise, we are having 192.168.100.1. This is a class C address because it starts with 192. So we are applying the class C subnet mask on it. So the class C default subnet mask is 255.255.255.0 comes in over here, which means that exactly the first 3 octets in the IP address is the network part, and the last octet 0 means this octet in the IP address, it will be the host. Similarly, another example 150.175.69.20 is a class B address because it starts with 150, which basically falls within the range of 128 to 191. So class B range, class A, class C, all these ranges very important to remember. So this particular 150 class B subnet mask, we are applying it from here to 255.255.0.0, which basically mean that in the IP address, the first 2 octets, 150 and 175 will be network. And last 2 octets we are having 0, so 69.20 will be host. Similarly, in a class A, this is your class A address 100.78.93.46. This is a class A address, so we are applying the class A subnet mask over here, which basically mean that 255, that is your 100, will be network, and remaining 3 octets is 0, so we are having hosts. Okay. So all these like for network and hosts, you are identifying using this formula. But there is an advanced version of subnet mask available, everyone. Okay. What exactly you are seeing in this topology, can you see that everywhere I am using this representation over here /24/24 like this? Can you see?
Yes, sir.
Okay.
Yes, sir.
Now what is it? This is the advanced way to represent the subnet mask, and it is called CIDR. This is the CIDR what we are having. Okay, now CIDR stands for what?
Classless interdomain routing.
Classless interdomain routing. And we are using it for what purpose? To represent the number of, just focus over here, number of what? N bits. N means what?
Network bits.
Okay, these are network bits, right? All these are number of network bits. What we are using to represent it using this particular slash. Okay, this slash over here. So what we are having is this default CIDR values. Okay, like your default subnet mask, you are having the default CIDR values, that is your class A, class B, and class C. Because we have class A, class B, and class C IP for unicast purpose. Okay. Okay, unicast means what? Unicast means
1-to-1.
1-to-1 communication, right?
Yes.
So we have all these 3 classes available in our IPv4 as well, right? In IPv4 public as well as private, right? In both types we have these 3 classes available. Yes or no?
Yes, sir.
Class
Yes,
B
sir.
is not available in private, class E is also not available in private. So these 3 classes are common in public and private. That is why we are having the default 3 classes available in subnet mask, and similarly the 3 classes available in CIDR as well. Okay. So this calculation comes from here, everyone. Okay, just focus on this definition properly. Uses slash notation to represent number of n bits. Okay. So we are using slash notation, and whatever value, okay, whatever value you type, okay, over here, it simply represents what? Number of
Bits.
n bits, right? That is your network bits. Okay. So it can be any value, whatever value. Okay, you write slash like what 10, 20, 30, like whatever value you type. Always understand, like what, remember that this represents the number of n bits, network bits in the IP address. So your CIDR notation, it basically is written like this. You type the IPv4 address, and after that you use a slash notation and you represent the number of network bits. Okay, over here. So these are basically our default CIDR. Class A, we are having how many ones? How many ones are there in class A?
8.
8
8
ones, right?
bits.
So 8 bits are network in class A. So we are simply just writing /8.
/8.
Similarly, in class B, how many bits are network bits?
16.
16, right? So that is when 16 is coming over here. And similarly, in class C, how many bits are network bits?
24, sir.
24.
So this is 124 is coming.
That's
Okay.
24.
Now, we are simply just mentioning the number of network bits in CID. We are not mentioning the host bits. If you see very carefully in your subnet mask, in subnet mask, you have to mention your network bits as well as the host bits. Yes or no?
Yes, sir.
You are writing 255.0.0.0. These are all host bits, right? And this is your network bit. Okay, this is your subnet mask. When you are writing the subnet mask, always you have to mention the network and host bits. But when you are representing the network bits over here using CID, then you were simply just mentioning it after slash here. Because we have this formula available. Your system, okay, all the systems, they always use this formula over here to calculate the number of host bits. They always know that your IP address or your subnet mask is how many bits address? 32 bits, right?
Yes, sir.
You have
Yes, sir.
32 bits address. So when I'm saying /24, what exactly it is doing?
8. Remaining 8 are host
Yes, it is subtracting this 24 network bits from 32 and it is getting what?
host bits.
8 bits host, right?
Yes.
This is done automatically by the system. Okay, all your systems, they perform this calculation automatically. Okay, that is why we don't have to mention our host bits because the system automatically calculates the number of host bits using this formula. Okay, this 32 bits address minus the number of network bits, what we are mentioning over here, it gives them the number of host bits. Okay, so when we are representing it, okay, when we represent, like when we build our network topology like this, always we represent it like this. Okay, /24/24 like that. Because subnet mask, when you are writing it, okay, it consumes time. Okay, specifically when I'm designing a network like this and I'm writing the IP address, it consumes time writing all this 255, 255, 255 like that. And that is the reason we are simply just using this notation to represent the number of network bits. So all of you simply just take a screenshot of this. Taken?
Done, sir.
Yes, sir.
Yeah, sir, taken.
So now we are having some calculation again. The powers of 2. The powers of 2 from 2 raised to 0 to 2 raised to 16 and 2 raised to 24. Very important. You guys are comfortable with this? Powers of 2? Everyone?
Yes, sir.
Comfortable,
Yes, sir.
right?
Yes, sir.
Yes,
So
sir.
2 raised to 0 is 1. 2 raised to 1 is 2. Then 2 is 4, right? 2 raised to 3 is
8,
8. 4 is
16,
then 5,
32.
then 6,
64,
64.
7,
128,
8,
256,
6.
9,
512,
512.
10,
1024.
11,
208.
12,
4096,
096
13,
8192
8192, 14,
16,
46384
16, 384,
32768.
32768
16,
65536.
65
and
36
24,
16777 216.
216. This is the table what you need to remember. Okay, because this is the same table what we are going to be using in the subnetting application. There is the concept called subnetting. Okay, is there. In the next session, we'll be starting this subnetting. Okay, but this table I will be using it. So, like what, memorize these values up to 2 raised to 16 from 2 raised to 0 and this 2 raised to 24. Okay. If you remember up to this will be fine. Okay. Now, this is your octet. You are having this octet. How many bits are there in an octet?
8.
8 bits, right? So, a bit is what? What is a bit? These are bits, right? Yes or no?
Yes, sir.
All these are
Yes,
bits. But what is a
0
bit?
and 1.
0 or 1, not 0 and 1. Your bit can be either 0 or
Oh, 1.
1. Okay. So by default, what is the minimum value of an octet? The minimum value, 0. In an octet, the minimum value is what? 0.
0.
And the maximum value is what?
255.
255. So from 0 to 255, total how many values we have?
256.
256. So if anyone is asking you that what exactly are the number of values we have in an octet, what are the total number of values? Your answer is
56.
56. But if they ask you that what is the maximum number we can give in an octet, then
55.
55. And what is the minimum number we can give in an octet is
0.
So always this conversion, okay, we can do it very easily. Okay, this binary conversion. So this is your binary number of bits of a frequency. These are the values of the powers of 2 everywhere. Okay, all these bits they have values. Okay, depending on their position. This is the rightmost bit, and this is the leftmost bit we are having from right to left. Okay, so this bit value is what? What is the bit value?
1.
1. Then this one is
2.
then
4.
4. Then
8.
then
16.
then
32.
then
64.
then
128.
120. Okay. Now all these values are coming from this power zone, as you can see, right? From here.
Yes, sir.
Okay.
Yes, sir.
Now using these, what exactly we can do? We can do conversion, binary or decimal to binary conversion. For example, let's say that we have 160. Okay. 160. This is a decimal value, right?
Yes, sir.
Now, using this particular table, how we can find out the binary numbers? Very easy. Just find out those values which gives you 160. You are having all the values, right? Which values you will be adding them to get 160? We need 128, right?
8 and 32.
128 plus 32 gives
32.
you what?
32.
160. Yes or no?
Yes, sir.
Yes, sir.
Only 120 plus 32 gives you 160. So we need 128, right?
1.
So it will be what?
1.
And we need what? 32?
1.
Yes, sir.
1. So it becomes what? Total becomes
1 0 1 0. 160. 0 0 0.
1 0 1 0. Then
0 0 0 0.
this is a binary. Okay. Now let's take another example. So let's take another example. Let's say 252. For 252, we need 128, right?
1 1 1 1 1 0 1.
So 128 plus 64 is how much? 120 plus 64?
192.
192. 192 plus 32 is how much?
224.
224. 224 plus 16?
40.
240. 240 plus 8?
48.
48 plus 4?
52.
252, right? So we need how many values? How
5
many
bits.
values we need?
1
Six,
1
right?
6.
1 1 1.
So it becomes 1,
1 1 1
1 1 1 1
0
1,
1
0
0
0
0
1. Then we are having the last two values 0
0 0.
This is your 252. All of you are getting it, right?
Yes, sir.
Yes, sir.
This is what you are having, the conversion. Okay, any values you can convert it like this. Okay, this is an octet representation. Any value you need to convert in an octet. This is the formula by which you can do that very easily using the power software. Okay, so this is what exactly I need you to take a screenshot. Simply just take a screenshot of the whole thing, everyone. Take a screenshot. Taken?
Done, sir.
Take this. Taken.
Done, sir.
Then the last part is this. Okay. Now here you are having three conversions going on. This is what? Which notation is this?
Class A.
No, which notation is this?
Oh, sorry, CIDR notation.
CIDR notation, right? Slash. This is which notation? Subnet mask.
Subnet mask.
And this is which notation?
IPv4.
Host part and the network.
Host and
Binary.
Network part and host part.
Binary. Binary. This
Binary.
is binary, right?
Yes.
Yes.
This is your subnet mask.
Subnet mask.
And this is your
CIDR
CIDR.
notation.
Okay.
Side.
So what exactly you will be doing is you will be making a table. This table you will make it. Okay, you will be making three headings. This one will be CIDR. This one will be subnet mask. And this one will be binary.
Binary.
Very important table, everyone. Okay, this one. Because I will be using it in the subnetting. In the next session itself, I will use it. So what I want you to do is basically make a table, make three columns, okay, three columns, make three headings in those columns and write all these values. This is your homework. Understood? You will be preparing this table and you will do this conversion. Okay. How you are doing this conversion? Very easy. /8, /16 and /24. These are our class A,
Yes, sir.
class B and class C subnet mask, right? Yes, sir.
Yes, sir.
So
Yes,
from
sir.
/8 to /16, you are having all these other values coming in, right? /9,
Yes, sir.
all these values. Then from /16 to /24, all these values are coming in, correct?
Yes, sir.
Yes, sir.
And from /24, we have all these values are coming in. The formula is very easy, everyone. The formula says that whenever we are having more than /8, always we have to count from 8 network bits. Like /9 is there. So 8 plus how many? 8 are your network bits, right?
Yes,
How
sir.
many
Yes,
more
sir.
network bits we need?
One more.
One more.
One more.
So this is our one more, right? 8 plus 1, 9. So what is the value of this bit? What is the value of this bit?
9.
This is the
9
bit
bit.
128, right?
128.
Yes, sir.
128 and
128,
128.
sir.
So can you see this 128 is coming here?
Yes, sir.
This is the
Yes, sir.
second octet, right? This is the second octet.
Yes.
120 is coming. For example, /10. 8 plus how many?
120, 64.
128 and 64.
So 2 network bits you need. 120 plus 64. So it becomes what? 192. Similarly, /14 or /14. 8 plus how many more?
6.
6.
So 6 network bits gives you what value?
252. 128, 64, 32, 68 and 1.
252, right?
252.
Yes. That is the same way. For example, if I talk about /19, then 16 plus how many more?
3.
3.
11.
So 16
Three,
plus 3
three.
is what? 3 bits means 224. Right?
224.
128, 64 and 32. 3 bits you are having 224. For example, if I talk about /27, then 24 plus what? 24 plus how many?
3.
3.
3.
Can you see the same thing continuing? What we were seeing over here, right? The same thing is continuing over here. Can you see that?
Yes, sir.
Yes.
In the second octet, whatever was happening, from the third octet, the same thing is happening. And similarly, from /24, it is happening on the fourth octet. Yes, sir.
Yes, sir. Yes, sir.
So your network bits always moves from which direction?
Left to right.
Left to right. Right. From left to right it is moving.
Right.
And
Yes.
your host bit is moving from
Right to left.
Right.
right to left, right? From right to left it is moving. So exactly opposite of one another. These host bits are moving. Okay, host bits and network bits are moving. This is what exactly is a table, everyone. This is a short calculation. You can simply just memorize this with values. Okay, simply just take a screenshot of this. Tomorrow I want to like what all these things, everyone. Okay, like in the next session, I want all these things just memorize all these values properly. Okay, if I ask you /25, immediately you should be telling me that this many number of ones are there. This is the value we are having the subnet mask. Every single. If I ask you that, okay, what is the CID and notation of this subnet mask? You should be telling /22. If I ask you that, okay, what exactly is the subnet mask of this notation, then you should be telling me this value immediately. Okay, so make sure that you practice it properly. All of you have taken the screenshot, right?
Yes.
Yes, sir.
Yes, sir.
Okay, very good. So simply just go through all these things. Okay, in the next session we'll be having the subnetting related things. Just hold on, let me just take the screenshot. Okay, all of you. So I will see you guys in the next session. Okay, and in the meantime, just do all the practice
Okay, sir.
properly.
Thank you, sir.
And make sure that you can like what you can do the conversion of this binary CIDR and subnet mask. Okay, very easily. Remember the powers of 2. In the next session itself, we like what we need all these things. Okay, all these things will be required, everyone. So make sure that you have it. Okay, ready. So I will see you guys in the next session. Okay, bye and take care, everyone.
Okay.
Thank you.
Okay.
Okay, sir.
Thank
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.